All right, then let's get started. Welcome everyone. Today's webinar about the 5 stages of event-driven architecture with Kafka. My name is Joey. I do the marketing here at Axual, and on the other end of the screen is Jeroen. You can go to the next slide, Jeroen. Anyway, Jeroen is going to be the host of this webinar and is going to do the presentation as well as a demo of the Axual platform.
All right, can you sorry for the disturbances, Joey.
No
clear
worries, no worries. Okay, cool. If you can go to the next slide and also the next one. So welcome, Jeroen, good to have you.
Yep.
So the agenda for today, first of all, we're going to discuss the journey of event streaming within enterprises. So we're going to walk through the maturity model, which contains 5 stages. Then we're going to discuss the customer success studies or success stories that we've seen at Rabobank and Volksbank. They both use Kafka at a very large scale. And we're going to end this webinar with a demo of Axual, and we're going to do the live Q&A. So if you have any burning questions around Kafka or about how to get started with event streaming, then make sure you stay at the end and ask your questions to Jeroen. First of all, before I forget it, this webinar will be recorded and I will share the recording with all the attendees, so no worries about that. Let's get started. Jeroen, floor is yours.
All right, thank you very much, Joey. Yeah, sorry for the audio. I think it was just my laptop, but everything is clear now. So let's get started. We're going to discuss several stages of adoption of event-driven architecture. And to guide us through this presentation, we're going to use a maturity model that Gartner has produced on this some time ago, which is the following. This is really organizations starting with event-driven architecture from day one, and then leading up to a situation where many different systems are just pervasively using events. It starts with the incidental phase. In the incidental phase, this is really the age that you can consider as being before Kafka. And this is the phase where there's no organization around handling events. This is usually the phase where enterprises, they find themselves being bombarded with information, not really organizing themselves around events just yet, but data is coming in from all different sides of the organization. So think of the customers sending them information through websites, mobile apps, shops, storefronts, etc. But there's also suppliers and business partners that send information about status updates, delivery updates, location, pricing updates, all kinds of things that you can imagine a supplier sending to you on a continuous basis. The organization usually has a lot of internal data sources as well. If you have, I don't know, an asset-intensive industry like railroads or the energy sector, there's probably a lot of sensors and meters that give you readings all the time. You can have certain alerts being sent to you from your infrastructure, but maybe also from other systems that you're operating. You have applications that generate events. If you do transaction processing or you do some other type of processing, those applications, they may send you events. And also we have lots and lots of processes, BPM coordinated. So at the end of every BPM process step, you can imagine an event being sent to you that this process step is completed. Also from external sources, there's a lot of information flowing in from social media, from news sites, weather information, market broker information, governmental information about citizen registries or about public addresses that were updated. So data flowing in from all sides. And what enterprises have done in the past decades is to build out a standardized way to handle this information. And it roughly falls apart into 3 steps. First step would be to collect information, to ingest it, to filter it, route it, and make sure it's ready for downstream processing. The second step is to interpret the information, to associate it with existing information already in the company. So this is where the brains are applied, the smartness is allocated to the data. You process the data and you calculate maybe some options to weigh further downstream. And finally, we want to make decisions based on the data. So you weigh your different options, you decide whether or not to take an action. And if so, you put a plan or an action in motion. Now, what organizations are faced with that haven't dealt with structural event processing just yet is that the number of data sources is steadily increasing. More and more data sources need to be hooked up. More and more data is flowing in. The volumes of data is increasing. The frequency of data is increasing. And also the speed at which the data must be processed is increasing heavily. So especially in this phase, people want to get organized around, can we handle this a little bit better? And there you see, you've automatically throw into a next phase where there's a need for a brokered way of handling information. So instead of bilateral agreements between applications or non-organized agreements between applications, you now start to think about, could I handle this better by having some sort of a general ingestion platform for data? And that ingestion platform would be the local Kafka or a local event broker that you put in place to get that data on firstly, after which you start to process. Typically, when organizations start to worry about this kind of event broker, information broker, they look at the market to see what kind of streaming engine to choose. And then you typically have 3 categories of options. This list is by no means complete, but I think that categories are pretty much complete. So you have software as a service options from the major cloud vendors. You have open source options, and there are a couple of proprietary options. And what we see in practice is that, well, there's a big engineering effort involved. So people like engineering tools. Apache Kafka has really a nice set of properties. It's really popular. It has a tremendous good functionality. Quality over cost is a very positive ratio, and it's proven in many different environments. So what we see, I think, in 2/3 or maybe even 3/4 of all the considerations, Apache Kafka is chosen as the preferred engine for data streaming. But then Kafka also can give you quite some challenges because it does have a steep learning curve. So it's not easy to get to know the technology to an extent where you can really set up a robust platform that you can also maintain as a business critical or a mission critical system. Maintenance day 2 is often feared. If you have a project team that is supposed to be, a feature team to set up certain functionality for a certain business application, at some point, if you consider Kafka and if you allow the feature team to set up a Kafka, at some point it will have to be maintained. It will have to be upgraded. And this really requires focus and requires infrastructural and middleware knowledge to do correctly. Kafka is also a platform which can give you a real high complexity of failure scenarios. There's a lot of things that you have to take into account to make sure that the platform operates stably and the business functionality can actually rely on its availability. Now, over time, we do see that many organizations have these kinds of feature teams that are setting up their own Kafka. So it is a solution to, getting around the challenges in the first phase, but it gives some extra challenges. And then, when you have 3 or 4 different Kafka platforms already in your organization, automatically, to solve these next level challenges, the question will rise, does it make sense to have a central Kafka? To not see Kafka as something that is maintained by a feature team, that is maintained by a department or that is maintained locally for exchange between 2 or 3 applications. But could we offer this as a central building block for the whole organization to work with, and that the whole organization can just configure their own piece of the pie, and to offer this from a central perspective. So what does that look like? Well, generally you would get a picture like this, where you have a centralized Kafka with all of your departments neatly organized around this central Kafka. And so marketing would be exchanging marketing events with other applications. Logistics would do logistics events, and everybody would post their own events and collect the events of other departments that they would be interested in. This is very much doable with Kafka, and this is also something we see occur in practice quite a lot. But this also comes with its own challenges again, because as soon as you start to set up an architecture like this, you run into stakeholders in the organization that also want to have certain features implemented in a platform like this. Well, the typical personas that you run into are depicted here. First one, and maybe even the most important one at this point, would be a data owner. And especially in a regulated sector like finance, you would expect data owners to be really keen on remaining in control of their streaming data. As you know, Kafka is a publish-subscribe platform. So that means that if you produce your information, if you publish your information onto Kafka, how can data owners remain in control of who gets to see what data? This is crucial for them, because at the end of the year, they have to answer to a regulator that the data didn't fall in the wrong hands and the processing was done in the right and intended way. So giving data owners control is crucial in setting up a central Kafka. If you do so, then of course, there's plenty of alternatives around Kafka, plenty of vendors to choose from. So that means that IT architects would be doing product selections. They would be looking for a Kafka that gives you good security and proven track records. Developers, on the other hand, they have their own stakes because they remember the time of the enterprise service bus, where there was a central ESB team, and every time they wanted to integrate with the ESB, this central team played a crucial role in their implementation, which is why the team was often overloaded with work. So if you were a developer and you had to integrate with the ESB, it probably was taking 3 or 5 months before your task was actually executed. And this is, in the DevOps way of working, a no-go nowadays. So developers are looking for independence. They should be in control of their own backlog execution. They want facilities. They don't want dependence. Operators would be looking for predictability, maintainability. If you operate this platform on-premise or in your own private clouds, you want to have as little fuss in the operations as possible. And finally, procurement says, well, it's nice that you selected Kafka. Kafka is open source, but I still want to have a credible vendor behind Kafka for if things go not so well, I want a party to fall back on, to call in support and to make sure that the business requirements of this platform are actually met. If you explode all of these requirements into, all of these needs into typical requirements, you get lists like this. So a data owner would be looking for features like data governance, for lineage, for GDPR compliance. Architects would be looking for a security architecture, for data replication, hybrid cloud solutions. Developers would be looking for CI/CD, for self-service, etc., etc. Now, if you then map, what Kafka offers you out of the box, it's not that much because Kafka is really the streaming engine. So it takes care of the data movement, but it doesn't necessarily take care of all these enterprise features on top. So it does offer you the streaming technology. There's plenty of vendors around Kafka, so it's open source. So plenty of distributions or plenty of vendors to choose from. And Kafka itself can be really treated as a proven solution because it's operated by many different organizations already. So proven in a lot of use cases, in a lot of scenarios. So in that sense, Kafka itself is a safe choice. It's just that all the enterprise challenges around Kafka are not met by Kafka itself. So what does a Kafka team then starts to do? They start to build their own governance mechanisms. They want to give those data owners the sense of control. So data owners should be given that control, meaning that you have to have some sort of a governance mechanism to put in place around providing access to certain data to certain applications. The foolproof security is key because you want to guarantee that no parties that shouldn't have authorization still get their hands on data that they shouldn't see. The developers are requesting self-service, which means that every developer should be able to log into some portal or some environment where they set up their own piece of the generic platform. And that team has to start supporting the whole Kafka stack, which can lead to some challenging situations, because if multiple teams within the organization are dependent on your platform operations, then it better be a good architecture, but also be supported in the right way. And then you come to the situation where many banks or many other organizations, they work with external people, with system integrators, and it's easy to hire them during the daytime. But what if the system breaks at night, or what if the system breaks on Christmas Eve? Then you still want your business to be able to continue. So supporting the whole stack means quite a lot, because it's really a 24/7 operations that you need to take care of. But if you manage to overcome this, then the world is your oyster, because after this, the technical challenges are pretty much solved. After this, if you go as an organization from the centralized phase, you can easily step to an advanced phase and a pervasive phase. And that doesn't mean that these phases are not containing their own challenges, but it means that the technology bit is pretty much in place. So if you go on beyond the centralized phase, what kind of challenges would you then face? Well, it's mostly the architectural and the organizational challenges. You have to start defining organizational standards. So what types of information do I want to exchange with whom? Think of messaging formats. Think of a standardized way to express what a customer is or what a bank account is. You have to start governing those Kafka catalogs, a topic catalog, a data catalog. You may have to integrate that with a master data management system somehow. What you also need to take care of is that teams are able to onboard quickly. This generic platform is out there for the world to use, for the internal banking world to use. So that means that if a team wants to be onboarded, they should be able to do so within, well, limited amount of time. I would say days or max a few weeks. But it's up for them to learn about the platform. Documentation should be in place. The procedures to onboard them should be in place. They have a box or a desk to go to in case of questions. So that whole process should be as smooth as possible. And also the scope of the entire Kafka grows, which means that Kafka may be a component that payment processing starts to depend on, or customer support starts to depend on, or I don't know, a mortgage status updates start to depend on. And as Kafka becomes more like a crucial element in many of these processes, that means that you have to make sure that the SLA of Kafka is in place and the organization is supported in all the right ways. If you do run into these challenges, I think we at Axual have seen many of them. We started to create a platform out of a banking need for a centralized Kafka. I will tell you a little bit in a few slides. I will tell you a little bit about our first use case at Rabobank, which was one of the top 3 banks in the Netherlands, where we started to see what was needed in practice in a big bank. the Axual platform became this technology solution to what we think banks need in a centralized Kafka environment. So we don't modify Kafka necessarily. We provide 100% Kafka compatibility, but we do provide a layer on top of Kafka, which makes it easy to manage a central Kafka. If you have an on-prem operation and you also are migrating to cloud, we would be able to have a Kafka cluster on-prem linked to a Kafka cluster in cloud for your applications to exchange information transparently. Security is in all the right places, built up from the ground. Self-service is there, topic management is there, etc., etc. So I will show you this in a few minutes in a demo as well. The basic thing is how to position Axual. Would be, what Red Hat is to Linux is what we are to Kafka. So we take open source Kafka off of the internet, we add management tooling on top, we package that into a nice distribution and make it as one big installable platform. That includes architecture, design, and a whole lot of choices that we made along the lines, which help organizations to set up the central Kafka quickly without having to worry about all the underlying technical details. So in a way, Axual is the ready-to-go distribution for Apache Kafka from the centralized phase onwards. If you're setting it up for a local team, you can probably cut some corners in terms of data governance or in terms of permissions and authorizations and security. We don't do that. We really built up those features from the ground, and there's no getting around to them. There's no getting around them. So as soon as you start to move to a centralized phase, where data governance is becoming more important, where you have to provide guarantees about handling of data, this is really where our platform comes around the corner as a solution to many of the challenges faced there. And we do fulfill all of these enterprise requirements that we talked about earlier, not by improving on Kafka itself, but providing the proper management layer on top of Kafka. So how do we do that? Well, we separate the several layers in our platform. We distinguish an infrastructure layer, which is VMs with Docker. Well, it was VMs with Docker in the past. Nowadays, it's all Kubernetes. So we assume a Kubernetes infrastructure to be there. We don't provide Kubernetes, but we do have some demands on its configurability. But assuming Kubernetes is there, the two layers on top is what you get with our platform. First up is a streaming layer. And this is really where you deal with the data logistics. You can have a Kafka cluster located in a data center somewhere. You can also have a Kafka cluster in a cloud region somewhere. At this layer, you would deal with one or more of these Kafka cluster and decide on where data needs to end up. So if you want to integrate a cloud Kafka with an on-prem Kafka, this is the layer where you would make these kinds of decisions. This layer is really operated by a technical maintainer, a Linux person, a Kubernetes person, somebody familiar with the command line, somebody familiar with Prometheus, Grafana dashboards, being able to operate a system and monitor for performance and availability. This person is typically not somebody that deals with data formats, with topics, because that is completely left up to the data governance layer on top, where individual teams get a login and they're able to configure, their part of the platform. I will show you that in a minute in the demo, but roughly speaking, if you have a role of data owner when you log in, and this is typically somebody with the data responsibility in the organization, if you have that role of data owner, you would be able to set up a topic, you would be able to set up the data formats on the topic, but that would be about it until an application owner logs in. It could be a solution architect or a lead engineer of some team. That person would log in, register their application, and then look in the topic catalog and find out what topics are there to access. They can then request access to a topic either as a producer or as a consumer. And as soon as that is done, then the data owner will get a notification. Somebody wants to access your data. Do you agree? Do you deny? And if you agree, then the access is granted on Kafka right away. So that means that there is an interaction game played between the application owner and the data owner, and the data owner still has full control of who gets to produce and consume on that topic. Of course, the teams responsible for applications, they still create streaming applications as normal, and this can be done with any kind of technology. You can do this with Java, with .NET, with Python, or any other language. You can even hook up the standard applications or standard connectors that other vendors may offer. So if you look at SAP or at Pega, they all have, Kafka connectors. These would basically work out of the box with our platform because we don't modify anything on the Kafka layer. This technical interface is still there as with any other Kafka platform. What we do add to the developer experience is that besides having a self-service UI where everybody can log in and navigate through, set up their own things, behind this UI, there's also a REST API that fully controls the whole metadata of the platform. And this REST API is available for anybody to also use in CI/CD or in GitOps kind of ways. Well, and together, it's the data governance on top of the streaming platform that we think makes up an enterprise streaming platform, because it's really the collaborative features and making sure that everybody in the organization can play its own role that collectively makes up the enterprise platform that we see big banks are looking for. And as a reference case, this was actually, Rabobank was the first customer that we worked for. This is where we started to play around with Kafka and found out in practice that there's a lot of functionality missing around Kafka, specifically for banks, for organizations working in a regulated sector in general. Rabobank wanted to have this central solution where events could be shared and captured by any other application in the organization. We started out to create the whole Kafka platform, and initially we were this central Kafka team. So it meant that we had a functional mailbox and we got requests like, can you create this topic for me, or can you allow that application on this topic? And in the beginning, we were the central team that everybody depended on to roll out these configurations in the operational platform. But then we quickly found out, that the demand for these functional changes could be easily satisfied by people themselves using a self-service environment. And this is introduced in 2018. And this is the left-hand side of the graphs on this slide. So all the three graphs, they start with mid-2018 somewhere, where we introduced self-service, and this was the status back then. The right-hand side of those graphs is January of this year. So you see that in 3.5 years' time, the amount of streams in production went ×7. In DTA, in non-production, it went ×7.5, and the amount of registered applications went ×8. And this was all in a period where we reduced the headcount of the central team from 6 down to 1 FTE in 2021. And so it's a tremendous increase in productivity and a tremendous increase in uptake. Presently, there are over 300 data streams in production, and there are 150 different teams working in parallel on the same platform, all with the same common Kafka underneath. The second case is the Volksbank, which is the fourth biggest bank in the Netherlands. They operate under a number of labels, amongst which ASN, Regiobank, and SNS Bank. They are following much in the footsteps of Rabobank at the moment, working on a cloud implementation where Kafka is deployed in a cloud environment, a private cloud environment, and use cases are being onboarded in much the same way. So Kafka is the central facility in the organizations for all other teams to use. And now it's many teams are coming on board to make use of this generic functionality. Demo time. I do see a Q&A question coming up. Ramnik is asking, what does a central Kafka mean? One stack of broker cluster. How about having multiple domain-specific clusters? Yes, you could have this. So what we do see is that organizations, they'd like to facilitate the information exchange between any domain. So that means that the marketing domain, the payments domain, the lending domain, the investments domain, they should be able to exchange information. And you can do that, of course, by setting up domain-specific Kafka clusters. So investments would have their own Kafka cluster, lending would have their own Kafka cluster, and facilitate information exchange somehow between those. What we see happening more often is that instead of setting up these departmental clusters, organizations would consider setting up a central cluster and then have that usable organization-wide. I hope that is a clear answer. Let me draw up a new browser window for you. There we go. So this is a small demo of Axual Cloud, which is the cloud platform that we operate for our customers. I have my own demo environment here, which I can log into with Google, which I will do now. Of course. And let me navigate away from here. The first thing to notice, if you go here on the left-hand side, one of the crucial things for a central Kafka is the ability to see what is already on the platform. And this is probably one of the first questions that you get. If a new user comes along, they want to see, what the usefulness of your platform is. Obviously, you would get the question, what is already on there? Is there payment information? Is there lending information? Is there mortgage information? Is there something that I could already use which would draw me to your platform? So what you see here is the topic catalog, which displays, don't mind, because this is really a demo environment, so I hope you don't mind the naming that much. But in this environment, in this list, you would see what topics are already residing on the platform, what kind of data you can expect to be there. So let's look at an example here for account entries. For account entries, you see that we keep some metadata associated with this particular topic. So there's a description. So this is, a topic that contains transactions of a non-existing bank. Very importantly, there is an owning team assigned to this particular topic. You can see here that I am part of this team, which gives me the access rights to also modify this topic. So it gives me the edit stream button here, and it also allows me to configure the topic deployment for specific environments. There is a key type and a value type associated with this topic, a retention policy. And you can see here that this topic is deployed in a number of environments. So in the development environment, it currently has one consumer, graphically depicted down here. We use a key and a value type version 1. In the acceptance environment, the same topic also exists, but it has a producer and one consumer. And you can see that in production, there's also one producer here and one consumer here. Now let me show you a little bit of the interaction on how it works with getting access to a particular topic. Here you see one application, the account entry service, which would be producing the account entries on this topic. What I can do as the topic owner, the data owner, is to remove this authorization. I can remove this, and this will automatically result in an update of the picture, but also automatically update in an update on Kafka. So this application is no longer authorized to access the data on the topic anymore to produce to the topic. But I can restore this, and going back to the catalogs. Besides the topic catalog, there's also an application catalog. Here you see the lists of all applications that are currently able to connect to Kafka. So this would be a list that gets created by your lead engineers, by your DevOps teams that are responsible for your application landscape. The service that I just revoked access for is here. You see that it's consuming from one stream, or it wants to consume from one stream. This isn't yet authorized, and it wants to produce to a test stream. But I want to restore its ability to produce to the account entries topic. So I can put in a request. I want to produce to account entries. You can see that's already approved on acceptance, but I now request approval to be able to produce on production again. And now it turns up here. It's grayed out, which means that the access request is out there, but it hasn't been approved yet. If I navigate back to the topic, normally, of course, it would be a different user, a different owner than the person responsible for the application. But for the sake of speed, these two have the same owner. But now, as a data owner of this topic, you can see that there is a pending request down here. Somebody wants to produce to your topic. Do you approve or do you deny? And if you approve, then the request is approved. Everything on Kafka is automatically set up. This application turns green, meaning that it now has access again to the topic, and it can connect and restart its producing. Now, what is nice is that because you know all of these relationships, you know what flows are visible, are currently deployed in your different environments. So in production, currently there is one service that produces to two topics, one of which is read by a secondary service, which outputs its information to a third topic. In acceptance, you could have a completely different situation, because in acceptance, you obviously have the next version, the next iteration of your production environment on the way. So this would be the situation in acceptance, and in development, you can have a completely different situation. And these pictures can get fairly complex, especially if you look at production situations, the situations that we encounter with our customers. These pictures can get fairly complex. What we do provide with these pictures is an always actual overview of what is currently going on your Kafka. And this is a major tool for architects that have the responsibility to provide this overview, to understand what is going on, but also for privacy officers, for security officers, because they can always see what is currently going on the platform. Besides showing these pictures, what we support is, coexistence of topics next to each other on the same Kafka. So you don't have to have many different Kafka clusters. We see many organizations that have a dev Kafka cluster, a test Kafka cluster, and an acceptance Kafka cluster. We have a namespacing feature in our platform, which allows you to have development and test and acceptance and maybe other non-production environments coexist next to each other on the same Kafka. So you don't have to manage that much Kafka anymore if you deploy it internally or in your own private cloud. And you can have a second Kafka cluster, which would then contain all the production information. I think I'll leave it to this for the demo for now. And go back to the presentation. All right.
Yes.
And that means that
Perfect.
we go to the Q&A.
Yes, definitely. Thank you very much, Jeroen. Yeah, so it's time for the last part of this webinar, the Q&A. We already answered a question, but if you have any questions around Kafka or how to get started, event streaming, you name it, now is your chance to ask us your question. And in the meantime, Jeroen, I was curious. Could you explain some of the use cases that you've seen for data streaming in the finance industry across our finance customers? Some real life examples.
Yeah, there's many different use cases that we see, but they can be seen in a couple of different categories. There is a number of use cases which really build on the Kafka capability to exchange information in real time. Think of real-time alerting, fraud and anomaly detection, building up real-time dashboards. These are typically use cases where information from a part of the bank is used in another part of the bank. So transactions processed would be sent off to a Kafka cluster, and then an alerting machinery would kick in and check out all of these executed transactions and find out if a customer needs to get a push message on a mobile banking app, for instance. And that is something that you typically want to happen within, I would say, 1 or 2 seconds max. Building up real-time dashboards to see liquidity information. Also to do fraud and anomaly detection. And normally if you transfer money, then some authorization is given. The customer would already see the money being deducted from their bank account. But then formally, in most cases, the money hasn't left the bank just yet. You still have a few seconds before the money actually leaves the bank, in which you can raise a red flag that, you know, there's something around, I don't know, money laundering or around terrorist financing. And this usually is to be executed within a mere number of seconds, because otherwise the money does leave the bank and the transaction is irreversible.
So quite a variety.
That is one category of use cases, I would say. Another category of use cases is something I would tend to describe as if this, then that for business. It's like, you know, if a transaction executes, then we want this process to kick in. We want the transaction categorized, or we want to offload the transaction information to a data lake. This is really where, you know, speed isn't the crucial factor, but the fact that some events leads to some consequence. And designing this on an architectural level, on an enterprise level, is becoming more and more important, because the information is becoming more and more diverse. And this landscape is in constant flux. So you cannot design these kinds of landscapes anymore in a single application. It has to be done on an enterprise level. The third category, I would say, would be around streaming analytics, where you don't necessarily act upon every individual message, but you treat the whole stream as, you know, more or less the same kinds of messages flowing in, where you calculate averages, or you do anomaly detection, or it's these kinds of streams where, you know, the data content is calculated and upgraded, up-calculated in some way to get to higher level business events.
Right. Interesting.
Yep.
Okay. Hey, in the meantime, I see another question that came in. It's not in the QA box, but in the comment section, in the chat section. Jeroen, maybe it's better if you read out yourself.
Yeah, I see a question here coming in for what is the approach used for handling higher payloads? Higher bandwidth one, I mean. Try to interpret this question. We see loads increasing a lot around Kafka. Initially, it starts out with, we have a use case, you know, and well, it's going to handle, I don't know, 100, 200 messages per second. I set up a Kafka for this. Initially, it isn't as critical as, I don't know, transaction processing just yet, but it does need to continue. So you set up an SLA for that. And then over time, it becomes more and more business critical, and maybe even mission critical, that, you know, these use cases are supported. And also what we see is that higher bandwidth is necessary. Yeah? It starts out with 200, but then it ups to maybe 300, 400, or a couple of thousand messages per second. So once people start to realize what information exchange on a large scale can mean for them, they often come up with new ideas, new use cases, and new ways to interact with other parts of the bank. And therefore, it starts to put more load on this central Kafka. So the way that Kafka handles this is by allowing scalability on all sides. So you can scale your producers, you can still scale the Kafka platform itself, and you can also scale the consumer part. So having no bottlenecks in the system, or at least providing all the capabilities to scale on those three levels, allows for potentially infinite amount of information exchange between applications. I see another question from the same person. Is communicating with other message brokers possible, i.e. communicating with RabbitMQ? Yes, definitely. There's a lot of connectors available for Kafka. There's also a Kafka Connect framework that comes along with Kafka that allows you to easily ingest information from some external source, or to easily output information from Kafka to some external sync system. These connectors, we have a number of them that we support out of the box. There's a lot of them to be fetched off of the internet. And there's also the ability for you to create your own. If there's some system that you want to connect to internally, normally it would be a matter of, I would say, 1 or 2 weeks to set up such a connector by a fairly knowledgeable Java team, but really limited amount of time to set up a new connector. So yeah, definitely exchange with all kinds of systems is a key feature of Kafka.
Cool. I see another question coming in the QA box this time.
Yep.
Does Axual work with Confluent Cloud?
Good question. Axual normally comes out of the box with its own Kafka, but we do provide compatibility with other Kafka platforms. So we would then just be the management layer on top of Kafka, where other providers could provide their own Kafka, or could be used to handle the Kafka part. So yes, that is possible.
And I think that's it, Jeroen. I think we run out of questions. Yeah, let's end this webinar. Okay, that's it. Thank you everyone for joining us today. I will make sure to send out the recording and the slides, and a couple of case studies of the Rabobank. Thank you, Jeroen, for joining in the great presentation. And
thank you, Joey.
Talk soon. Have a great day, everyone.
Bye.
Cheers. Bye-bye.